complex numbers Argand diagram example. This example is taken from an OCR practice paper. It's a very difficult example of an Argand diagram question because it brings together various strands of the course, and it's not clear what method to use in which part of the question. It's also a question which asks for detailed reasoning, but then in part 1 it just says write down, which overrules the request for detailed reasoning. So you could just write down the value. Obviously, if you're unsure, you might want to work out omega 1 and omega 2 and then multiply them together. But what you're really expected to do here is to spot that this is to do with the roots of polynomial equations, and omega 1 times omega 2 is just the product of the two roots, and therefore that is c over a is 4, b is 4, c is 17, so c over a is 17 over 4. Job done. But now we've got to draw the Argand diagram with omega 1 and omega 2 on. But we're now in a sense thinking about roots of polynomial equations. We know omega 1 times omega 2 and omega 1 plus omega 2, but we don't know omega 1 and omega 2 themselves. So it's slightly awkward to actually break out of that mold and just say, well, I'll just work out what the roots of the equation are, and I'll call one of them A and one of them B. And once you've managed to make that leap, you just use the quadratic formula. You put all your values in, remembering you do now need to show detailed reasoning. You can't just write them down. You work on through and you end up with the roots being minus a half plus or minus 2i. You could then, of course, check it with your calculator, having worked it out. So having found what omega 1 and omega 2 are, we can now draw the Argand diagram. And this is what it looks like. We've got omega 1 times omega 2 is pure real, and it's over there on the positive side. Of course, because it was a quadratic equation, omega 1 and omega 2 are actually complex conjugates of each other. Because it's minus a half, that's the x coordinate, the real coordinate of the 2 points. One is plus 2i, one is minus 2i. The distance between them is 4. We have an isosceles triangle. There are various ways we can work out the area of this. The easiest way, I think, is just to say it's a half base times height. The base is a total of 4. 2 plus 2 is 4. And the height is 17 over 4 plus a half, 19 over 4. And our final answer is 19 over 2. And the problem is solved. It's not the only way of solving it, and I've got an example of a student solution here where he basically worked through it just using the roots of equations method. The fact that he drew a diagram is good. The fact that he's got omega 1 and omega 2 on the wrong side of the imaginary axis does not matter. He still gets the correct answer. So he managed to work out omega 1 minus omega 2 as the square root from this method here. So you could have done it by that and then do areas half base times height again. But the easier method, and the one that they give in the mark scheme, is to work it out using the quadratic formula or completing the square. Whichever way you go, hopefully you get the correct answer. Thank you for watching the video.